Welcome back to our ADIPEC On Air podcast series, live from the Wood stand here at ADIPEC. I'm Steph, your host this afternoon, and I'm joined by my colleague Dan Carter, President of Decarbonisation at Wood, and Daria Nochevnik, Director of Policy and Partnerships at the Hydrogen Council. Welcome both. Today we're delving into the complex hydrogen landscape and the projects that are transforming the use of hydrogen across our industry. So decarbonisation, net zero has been the focus of the conference. But what is the role of hydrogen in the decarbonisation space, and is it having a transformative impact on our global industry? I'll come to you first, Daria.
Thank you, and it's great to be here, and thank you so much for this excellent conversation. We are, of course, delighted to have Wood as Hydrogen Council member, and to those of you who may not know us, Hydrogen Council is a global coalition of CEOs that today represent over 150 industrial leaders in hydrogen across the value chain and across geographies, from the MENA region and Asia Pacific to the Americas and Africa. So we bring together the coalition of the companies that are indeed advancing from vision to action and implementing hydrogen projects across the value chain and across geographies. And we see indeed that the potential of hydrogen in contributing to the transition to net zero is enormous. Hydrogen can in fact help abating between 60 and 80 gigaton of CO2 by mid-century. And we see hydrogen play a critical role, in particular, of course, in hard-to-abate sectors, but also across the multitude of end-use sectors, and countries across geographies are currently exploring their own pathways and developing and designing their hydrogen economies. And another critical, of course, aspect of hydrogen is the fact that it can help us bring clean electrons and renewable electrons via molecules across long distances. And that, of course, has substantial cost efficiency as well as carbon abatement benefits associated to that. And, of course, we see enormous potential for the development of cross-border trade corridors that can help us optimize the energy systems globally and save up to 6 trillion in energy system cost by mid-century.
That's a key point, isn't it, Daria, that we've got geographies around the world where other solutions like CCUS might not be a practical option because they don't have the available stores to sequester CO2. So being able to generate hydrogen, capture that CO2 at source, if it's from a natural gas-based feedstock or from renewable-based feedstock import directly, is going to be key to helping decarbonise those geographies that perhaps are less geographically or geologically challenged.
Absolutely. And maybe just to build on that, I think that there is a growing consensus on the fact that we really need to move beyond hydrogen colors and the color-coded scheme, because it's not particularly helpful, and we need really transparency on the carbon footprint associated with hydrogen production, conditioning, and transport. And I think that it's very encouraging that we see that global consensus that arises in particular from the latest G7 and G20 discussions around the need for focusing in particular on carbon footprint and moving away from the color coding scheme. And the latest IEA report prepared for G7 also points to that need. And again, I think that that would help revealing also the carbon abatement benefits of a variety of hydrogen solutions, including, of course, CCS-enabled hydrogen, which will be critical going forward.
It's also very important, too, when you start to look at things like the Inflation Reduction Act in the USA in terms of the amount of the subsidy you can gather based on the carbon intensity, and maybe the cross-border adjustment mechanisms as well that are coming in place in Europe from that trading perspective, making sure we really understand that the solution we've got our hands around is of benefit from a wider decarbonisation scenario. It's a bit of an adjacency, but it brings me back to, I've seen the press release from Lego earlier on this week. So Lego were looking for alternative sources of plastic to manufacture their products. They've actually now pulled away from that somewhat because the alternative opportunities actually carry a larger carbon footprint throughout their entire life cycle than traditional product production routes, which is why it's really important to focus on carbon intensity.
Absolutely, yeah. And maybe just to add to that, I think that it's very positive that we see that while there is a plethora of national approaches and national methodologies that are, so the methodologies for greenhouse gas emissions assessment that are being adopted at national level, as well as different thresholds, of course, for qualifying hydrogen as clean or indeed sustainable. We also see that there is an effort internationally that is being advanced, I think, at a very good pace right now, to come up with a common global benchmarks. There is an ongoing work on the global ISO standard and an ISO methodology for greenhouse gas emissions assessment of hydrogen production, conditioning or conversion and transport. And I think that would be extremely helpful for us to have a common global benchmark against which we can compare the different, of course, production methods as well as transportation methods, ultimately to be able to compare apples and apples as we're seeking to develop a global market.
And the power of hydrogen lies not just in its environmental credentials, but in its versatility. How can carbon-intensive industries utilize this functionality, Dan?
I think the real power of hydrogen is to be utilised in those carbon-intensive industries as a fuel to displace existing natural gas. It should be a relatively cost-effective modification for many of those industries to transfer from methane to hydrogen end use, but providing actually reducing those emissions significantly in terms of intensity. The challenge that we've really got within the industry right now is developing the demand profile in parallel with the supply side. So, we see a lot of those projects that are being successful and are moving ahead right now. They're actually within integrated ecosystems where a particular organisation has either got an off-take partner or they have their own hydrogen demands to help decarbonise their own facilities that they can supply for a large portion of the hydrogen generation they're looking at. So it really is a challenge around how we kick off the scalability and deliverability of the hydrogen ecosystem.
And building on what you said, Dan, I think that the latest IEA report, Global Hydrogen Review, points to the fact that a lot of the support measures that decision makers are putting in place are very much on supply side, and actually demand side is really lagging behind. And what we see as absolutely critical going forward is actually for decision makers to focus on putting more efforts and actually focusing more on the demand pull measures. Because arguably, once we get those right, that would create ripple effects across the entire value chain. So we see that, for example, contracts for difference are emerging as some of the policy tools of choice to incentivize fuel switching across some of the end uses, as well as carbon contracts for difference. But also we feel that there is a critical need for legally binding targets and quotas. Yeah. Even if we look at Europe, there is a famous target, of course, of 20 million tons of renewable and low carbon hydrogen to be consumed in Europe by 2030. But if you look at the legislative requirements, they translate on the demand side, they translate into 5 million tons. So there is a big gap between 5 and 20. And we really need stronger demand pull measures in order to make sure that that ultimately the consumers are incentivized to switch fuels.
It's the Inflation Reduction Act, again, is a good example of that, isn't it? Because you can generate a credit for producing your hydrogen. Let's say if you generate a credit for capturing CO2, you could then combine those products into a e-fuel and perhaps take advantage of the clean fuels credits on top of that. But if you were to use that hydrogen to decarbonise, there is no incentive, unlike a potential of $85 a tonne if you were to capture that CO2 instead. So there needs to be something in place for that CO2 avoidance mechanism as well as just the capture piece.
And Daria, you've touched on a few reports, and I know obviously from being at the Hydrogen Council, you're in amongst the data, constantly looking at the facts or figures. Is there any other latest insights that you can share with us from your research?
Thank you. Yeah, absolutely. I think that if we take a step back and look into the development and hydrogen deployment globally, of course, we have a pipeline of mature project proposals, over 1,000 of those, and they could potentially translate into some 320 billion in investments by 2030. Now, of course, there is a big gap between announcements and the projects that have been FID'd. About 10% of those have been FID'd to date. Now, having said that, if we consider the total amount of investments committed into hydrogen, as of January 2023, we are right now at 30 billion, and we were at 20 billion a year ago. Now, that amount may seem not as large as we would like it to be, but it used to take the industry 10 years to get to 1 billion. And we jumped 10 billion within a year now. So if we take a historical perspective on the developments and hydrogen deployment that we see most recently, the pace of change and the pace of deployment is quite enormous. And we see really substantial growth in terms of the development and the uptake of hydrogen across the value chain. There has been a substantial rise in the development of the manufacturing capacity, electrolyzer manufacturing capacity. We saw 150% year-on-year growth just within a year, and we are at 8.8 gigawatt of installed capacity for electrolyzer manufacturing currently. This is just one example. We have over 80,000 vehicles, fuel cell electric vehicles on the road today right now. And the growth indeed has been substantial across the value chain, so both on the manufacturing production side as well as on the end-use side.
I think the key point there as well is there still needs to be more. I think the cost of CapEx cost of electrolyzer generation is still something like $400 per megawatt for alkaline, maybe up to 1,000 to 2,000 for PEM, even more for solid oxide-based technologies. So in order to bring down that overall CapEx point of deployment, we need to scale up manufacturing capacity significantly.
Absolutely.
To meet demand, especially to meet that $320 billion worth of projects in the development pipeline that you were talking about.
Absolutely, yeah, definitely. And of course, one should also not forget the fundamental challenge of ensuring that there is renewable capacity on the upstream side made available. And this is where we see critical, again, need for moving and synchronizing action on the industry side, and also on the decision makers side when it comes to permitting processes, for example, accelerating those, as we know that in the case of some of the renewable projects in particular, for example, large scale wind projects, it can take up to 6 to 7 years to get a permit, and of course that's not the pace at which it would help us to move forward with deployment of the relevant capacities that will be needed to feed the electrolyzers in the years to come.
Yeah, I think it's also interesting how the types and shapes of projects are developing. So obviously we've got a lot of emphasis on hydrogen production in Europe, where perhaps the renewables could have an alternative source directly to grid. But then also, we've been working on projects like the Total Eren project in South America, where you're looking at monetizing what really is a stranded resource there by transforming into hydrogen for export. The same with some of the unconventional gas to hydrogen projects we've been doing here in the Middle East. So you're starting to create those trade flows around that global ecosystem as well.
Absolutely, and this is indeed something that also our trade flow study points to, the fact that, of course, it makes a lot of sense to make the most use of the locations and places around the world where there is abundant potential for renewable sources, and then effectively transfer those clean electrons or clean molecules that could be generated thanks to technology such as CCS, and bring them to the main demand pools that are emerging in different parts of the world, in Europe and Asia in particular. And we see that indeed the producers in countries in the Middle East, alongside the US, can become some of the lowest cost suppliers globally in the time frame between 2030 and 2040 in particular.
Yeah, I think that applies to the natural gas production as well, because generally whole life cycle carbon emissions involved in the natural gas supply chain are probably less than they would be elsewhere because of the ease of production. So you see those dovetailing of the hydrogen generation technologies with carbon capture coming to play, as well as those transport mechanisms, whether that's ammonia, liquid organic hydrogen carriers, maybe in the future liquefied H2s.
Yeah, absolutely. And there is, of course, a great potential for making use of the existing infrastructure and repurposing it for the repurposing and retrofitting it for hydrogen. Of course, in the US, there is a wide network of pipeline infrastructure that can be used, and we see that hydrogen going back to your question about versatility, provides a unique solution to bridge the historical silos between power, gas, and liquid fuels, and really act as that integrator of the energy system. And we have actually most recently conducted a study where we have looked at the system integration of hydrogen across 3 archetypal regions. We looked at Houston in the US, Japan, and Central Western Europe, 3 very different regions in terms of their energy mix, in terms of the composition of the energy system. But we see some clear patterns and clear similarities in terms of the role that hydrogen can play, in particular in providing greater flexibility at system level, as well as, of course, massive cost savings alongside the carbon abatement benefits that we have discussed earlier. And of course, for this region, for the Middle East, there is a suite of opportunities for hydrogen to be used, of course, as an important export vector, but also for decarbonization and of local industries.
And you've both touched on a few different projects or initiatives or things that are going on globally, I guess. Was there any particular transformative hydrogen projects that you could tell us about? Something that really creating value for industry and potentially consumers as well?
So I think one of the projects that we're working on here in the Middle East is actually designed to produce 10 million tons a year of hydrogen using unconventional resources as the feedstock. So it's providing another opportunity to monetize that, again, fitting into that value chain where you're creating hydrogen, ammonia, exporting that ammonia to the Far East for use in helping decarbonize industry. So I think that's transformative because of the scale, the way the technology is being deployed at that scale for that particular project, and also the trade flow that is creating between the partners and that type of opportunity.
Yeah, I think this is an excellent example, and we see that it's great to see companies embrace some of this first mover risk, of course, that they are associated with these large scale projects, but these are indeed having a transformative effect for the whole industry as they effectively trailblaze the potential pathways and those trade flows that we expect to emerge going forward. So I think that we see, of course, that there are a number of also pilot projects emerging for liquid hydrogen. We have seen the first shipment of liquid hydrogen from Australia to Japan just last year taking place. And I think that these are also, of course, some of the examples that give us a flavor of the sort of expansion of the market that we may see in the next 2 decades.
Now, the theme of ADIPEC this year is decarbonizing faster and together. And this is something we're asking all of our podcast participants. Dan, you may have already answered this on a previous podcast. So, Daria, I'll come to you. We as an industry are already working to decarbonize. What is the one thing you think we need to do better to get there faster?
I think that it's absolutely key to actually communicate the value of the great efforts that are being done by the industry. And I think that there is so much, and there are so many initiatives, projects, and I think definitely putting ourselves out there and also communicating both the climate value and the social value of these projects is particularly critical. And we are actually designing an SDG roadmap for hydrogen, looking at the contributions that hydrogen can make to also the UN Sustainable Development Goals and the social value that it can help unlocking across different geographies. And I think that there's a great amount of good practices and excellent projects that are already being deployed by the industry. So I think putting the word out there and making those good practices and case studies heard will be absolutely critical going forward.
So I'm going to come up with a different answer today.
Okay.
So my answer today would be linked to the comment that Daria made about the communication to all the stakeholder groups. But I think it's actually starting to treat those stakeholder groups more like partners. So we are sharing common aligned strategic goals, common aligned values, and explaining the role in the industry has to play in that to help break down some of the barriers that we see, whether those barriers are around permitting, the acceptance of technology, the acceptance of consumers for different end solutions. So really important, but also important to encourage people to join our industry as well to help us drive the solutions moving forward.
Yeah, both important, both great. Thank you. And thank you very much, both of you, for joining us today and for your insight.
And thank you.
Thanks, Steph. Thank you, Daria.
Thank you.